at 2015 AP Calculus Free Response question number 5. Okay, so the figure above shows the graph of f prime, the derivative of a twice differentiable function f on the interval -3 to 4. The graph of f prime has horizontal tangents at x equals -1, x equals 1, and x equals 3. The areas of the regions bounded by the x-axis in the graph of f prime on the intervals -2 to 1 and 1 to 4 are 9 and 12 respectively. Okay, so they gave us a whole lot of information, so I think the best thing to do would be kind of go through and label some of this information on the graph, or wherever it applies. Okay, so let's see, the graph of f prime, so this is the graph of f prime, so you may want to like circle that or something just so you remember that. It has horizontal tangents at -1, 1, and 3. So these are all 0 slopes. Horizontal tangents are 0 slopes. Okay, so it kind of flattens out for a moment there. And the areas of the regions bounded by the x-axis in the graph of f prime on the intervals -2 to 1 is 9. So this -2 to 1 is 9. And then from 1 to 4 is 12. Okay? That's the area. Now, these areas are beneath the x-axis, so it's important to remember that these would both be negative because it's below the x-axis. Okay? Okay. Part A, find the x-coordinates at which f has a relative maximum. Give a reason for your answer. So on part A, when do I have a maximum? Do you remember? Maximums occur. F has a max when f prime changes. And let's think about what a maximum looks like. So maximum looks like this. So when it changes, the slope would be positive and then negative. So when f prime changes from positive to negative, and f prime equals 0. So just kind of being extra thorough, okay? So f prime equals 0 and it changes from positive to negative. So there's a few different places where this graph is equal to 0. I'm going to get rid of some of this stuff for now, just so we can kind of see maybe a little bit better. So it's equal to 0 at these 3 points, but it only changes from positive to negative at -2. Okay? From positive at x equals -2. So f has a max at x equals -2. Okay? Okay, part B. On what open intervals contained in -3 to 4 is the graph both concave down and decreasing? Give a reason for your answer. Okay, let's erase what we wrote up here. Concave down and decreasing. So we are concave down, or wait, what does it ask for? Concave down and decreasing. Yep, so concave down. When am I concave down in terms of f prime? Okay, so in terms of the first derivative, when am I concave down? And there's a reason why I'm using the first derivative, right? I'm using what was given to me in the beginning of the problem. So f prime is concave down, or f is concave down when f prime is decreasing. Okay, and then it says, when am I decreasing? So I'm decreasing when f prime is negative. Okay, so f is concave down and decreasing on some intervals because f prime is negative and decreasing. So let's take a look up at the graph and figure out where we are negative and decreasing. So we're negative everywhere beneath the x-axis. And now I want to figure out where I am decreasing. So I'm decreasing from -2 to -1 and from 1 to 3. Okay? So that's where I'm below the x-axis and I'm decreasing. So so my original function is concave down and decreasing. So I would say on -2 to -1, like we said, and from 1 to 3. Okay? That's where my graph of f is both concave down and decreasing. Part C, find the x-coordinate for all points of inflection for the graph of f. Give a reason for your answer. Okay, points of inflection. Points of inflection. Where do I have a point of inflection in terms of the first derivative? Okay, so in terms of the first derivative, we have a point of inflection when f prime changes from increasing to decreasing, or from decreasing to increasing. Okay, so let's take a look up at the graph here. This is all decreasing, and then I change to increasing, then I'm decreasing, then I'm increasing. So it looks like I have a point of inflection here at -1, at 1, and at 3. Okay, so what we'll do is we'll kind of break this up and maybe look at it point by point just to make sure we're thorough in our explanation. So f has a point of inflection. Whoops. Okay. Of inflection at x equals -1, right? That was the first point. Because f prime changes from decreasing to increasing. And then f has a point of inflection at x equals, what was the next point? At 1, and it looks like the graph is changing from increasing to decreasing. So at x equals 1, because f prime changes from increasing to decreasing. And then lastly, f has a point of inflection at x equals, let's see, 3, because the graph changes from decreasing to increasing. Okay. So from decreasing to increasing. Okay. So those are all the points of inflection. You could probably combine some of those, the ones that behave very similarly. So we could combine -1 to 1, or from -1 and 3, I'm sorry. We could combine that notation there because they are changing for the same reasons. As far as abbreviations go, it's okay to use abbreviations, but make sure they are understood and common abbreviations, okay? So I try not to use them for the main calculus words, but for some of the shorthands like for because or without, I might include them, okay? Okay, for part D, given that f of 1 is equal to 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. Okay, so part D. So it looks like I'm given an initial value, I'm given a derivative, and I need to find some function values. Any ideas what we're going to be doing on this one? We've seen it before. Okay, so for this one, what we're going to be needing to do is the fundamental theorem of calculus. And what that says is if I take the integral of f prime, I will end up with my original function. Okay? Right, so if we take the integral of f prime, we end up with my original. Now it did tell me that f of 1 is equal to 3, so I'm going to start this at 1, and I'm going to go to some value x. So that means I'll have to change the function on the inside of my integral to be something else, and this would be equal to f of x evaluated from, or f of t, evaluated from 1 to x. So the integral from 1 to x of f prime of t dt is equal to f of x minus f of 1. And it tells me in the beginning that f of 1 is equal to 3, so minus 3 here. So that f of 1 can change to 3. Okay. So I want to get f of x by itself, so I'm going to add the 3 over. So there's the first answer, right? And it says write an expression for f of x that involves an integral. So we did that. There's my expression for f of x involving the integral. And then it tells me to find f of 4. So f of 4 is equal to 3 plus the integral from 1 to 4 of f prime of t dt. So 3 plus, now remember what an integral represents, right? Represents two things, the area under the curve and an antiderivative. Now I don't have a function, so I can't find an antiderivative, so instead we'll look up at the graph. And from 1 to 4, it told us in the beginning of the problem that the area from 1 to 4 was 12. Now because this area was beneath the x-axis, this is a negative 12. Okay? So the integral here represents the area of negative 12. So when I add those together, I get negative 9. For the other f value, f of negative 2, we're going to follow the same process. F of negative 2 equals 3 plus the integral from 1 to negative 2, f prime of t dt. And now remember, the integral is not increasing, so what we'll need to do is change those bounds. So we're going to make it an increasing integral, and when we do that, we have to put a negative sign out in front of it. So 3 minus, and then it says the integral from negative 2 to 1, and it told us that the integral from negative 2 to 1 was 9. So this area beneath the curve is 9, or the area between the curve and the x-axis is 9. But because it's below the x-axis, it's a negative 9 when I talk about my integral. So minus negative 9, so this would equal 12, okay, when you add those together. Okay, let's talk about points. For part A, you're going to get 1 point for identifying x of negative 2 and 1 point for your answer with your reason. Okay? In part B, you're going to get 1 point for your intervals and 1 point for your reason. Okay? For part C, you're going to get 1 point for identifying negative 1, 1, and 3, and then 1 point for your reasons. Okay? 1 point total for all the reasons. Part D, you're going to get 3 points. 1 point for your integral expression, which we put right here. 1 point for your expression for f of x. I'm sorry, so 1 point for the integral. 1 point for your expression of f of x. And then 1 point total for these two. Okay? Okay, so there's your 9 points. All right. Let me know if you have any questions.